Hello everybody, and welcome to Lecture 1 on Unit 1. This unit is going to cover the basics, what is geology, how did the Earth form. Let's get started. First, geology as a science, Section 1. What is geology? This is going to cover some of the material that we covered in class on Wednesday. And real quickly, not going to spend too much time on this, treat this like a little problem that somebody hands you. They ask you, what happened here? What is the story? We notice rocks here have layers which are a little strange. They're pointed straight up and down. Rocks here are a little bit tilted, but mostly side to side. And there is this very interesting feature that runs right between them. That has to represent something, some event. What does that mean? We'll cover all this later. Moving on. What is geology? You guys spent some time on this in class, so we won't go too deep here. Geology is the scientific study of Earth through 4.56 billion years, that is from right now to about when the Earth was born. For the purposes of this class, we are mostly going to focus on physical geology. So this is going to be the study of Earth's physical processes and its materials. Now, real quick, geology covers sort of an entire universe of different places people can go and processes that they can study. So we have in the upper left here a geologist in a very interesting place, actually in Los Angeles, California. There, excuse me, that's he is on the moon collecting rocks. Here we have geologists listening to a volcano. Might be an exciting job, who knows? We have geologists here collecting ice cores from Antarctica. The idea there is very simple. We look at the old ice and we compare it to the new ice and see what's different and what that might tell us about what the climate was like. Here we have a diving geologist, probably an interesting job, looking at fossils. So what we see right here is actually a fossilized algal mat, ocean floor, trying to look here and try to figure out something about what was going on in this location many, many years ago. Finally, we have this interesting fellow in here investigating an earthquake, and some people behind him who maybe don't matter. So, why study geology? Some very important problems ultimately come into the universe of geology. For example, problems of energy, water, and mineral resources. The energy which turns on the lights in my office, the water that I drink, the raw materials that make up everything in this room. All of these ultimately are geologic problems in nature. Environmental problem solving is another one. And this has become especially important in recent years. People get closer together. It is harder and harder to be your own separate individual whose actions do not affect anybody around you. So there is an entire universe of environmental problem solving looking at contaminants and contaminant transport and how the actions of one person in society might affect the well-being of everybody who's around them. Climate change. And being in Arizona, this is especially important here. It's looking like, for better or for worse, the whole Earth is getting warmer, and it just so happens to be that we are in a part of the Earth that cannot stand to get any warmer. And finally, natural hazards. You imagine that maybe you live in an island nation which is subject to tremendous earthquakes coming along. These earthquakes are nation-threatening scale events, so you would put your best and brightest minds onto trying to predict how big these earthquakes are going to be, their frequency, where they're going to happen, and how exactly the waves propagate so that you know how to build your buildings and keep your people safe. And, well, maybe you as an individual are not going to be solving all these problems by yourself. More than likely, most individuals are never going to work as a geologist, so why would I care? I'm not solving these big problems, it's none of my concern. Well, part of it is that you live on this. You live on the Earth. Earth is all of our home planet. For now at least, for better or for worse, we are all going to be on the Earth from now until the end of our lives. We depend on the Earth for all of our material resources. Everything in this room, eventually, if we trace it far enough back, came out of the Earth. And because many of these resources are very limited, It's important that we have people who know something about the materials themselves so that we don't waste it. And, of course, what happens on the Earth, whether it's climate or some other forces, it affects everybody on it. We all have some sort of vested interest in all of our people knowing something about the planet that they live on. We must appreciate, finally, our role in geologic change. We are long past the days where the activities of humankind are unable to affect the planet as a whole. I'm afraid we're much larger than that these days. Following is a plaque located in Iceland, and I'll go ahead and read it to you very quickly. It says, "A letter to the future. Ok is the first Icelandic glacier to lose its status as a glacier. In the next 200 years, all our glaciers are expected to follow the same path. This monument is to acknowledge that we know what is happening and what needs to be done. Only you know if we did it." And this is from August 2019. Figure at the bottom, 415 parts per million CO2. I'm sure you know this already. This is a measure of how much carbon dioxide is in the atmosphere. This is the key element which we are adding to our environment that seems to be contributing the most to climate change. On a little bit of a different note here, in this class we're going to talk about many different theories. For example, theory of plate tectonics. But in a scientific context, I will try not to give you my own pet peeves here. A theory has a little bit of a different meaning from its everyday usage, right? You talk about, oh, well, I saw this movie and my theory is that this happened. In a scientific context, this is used in a little bit of a different way. In the context of science, a theory means the highest level of knowledge. This is something that we are so confident about that people will risk their lives on this being true, and we can use this as a foundation for further knowledge. It is that solid. It is something which is testable and repeatable and which has never been falsified. And finally, it's something that represents the scientific consensus on an issue. The consensus of experts will always outweigh the individual opinion of one expert. Stay tuned for Section 2. We're going to cover the history of geology. Bye-bye.